In this video, I will show you how to calculate non-compartmental and compartmental analysis parameters in your preferred units. This feature will give you more flexibility for reporting and will make the analysis more realistic. Units appear in the Data tab after accepting a dataset and are switched on with this toggle button here. The NCA and C parameters are combinations of these basic variables: time, concentration, and amount. For instance, AUC is a product of concentration and time. In case of urine dataset, we also need a volume of collected urine to define all parameters. These quantities correspond to columns in a typical PK dataset. So here, time of measurements, observed concentration, dose amount, and volume of collected urine. If we know units of these quantities, we can specify units of the parameters. So how does it work in PKanalix? Units block has three elements. Input data represents values in the four columns that I mentioned before. Output units define units of the NCA and C parameters, and the scaling factor allows to transform data to a different unit. As you can see at this point, to use units in PKanalix, you need to know the units used in your own dataset. You can look at this definition as a relationship between a quantity in the original units and a quantity in the output units. For instance, let's say that a dose amount in my dataset is in milligrams. So to display the results in micrograms, I need to multiply the values in the dataset by 10 to the power of 3. Or let's take a concentration. The original measurements are in nanomole per milliliter, but I would like to use liters instead of milliliters. A milliliter is 1,000th of a liter, but as it is in the denominator, I need a scaling factor 1,000. It works in the same way for time. Measurements in days in a dataset have to be multiplied by 24 to use time in hours in calculations. So let's now consider two examples to see how it works in practice. In the first example, I want to compute parameters in the original units of my dataset. For clarity, I just edit them in the header names. In this case, I select these units from the drop-down menus for each quantity. You can notice here the link between the complex unit of concentration and the unit of the amount. I changed it in the concentration line and it was automatically updated in the amount line. The same link is for the volume. This approach is designed to simplify parameters units. Now, after changing units, I have to accept the dataset again, and I can run the NCA task. Units are displayed in the results table below the parameter name. They are also in plots and in the text files with the results. In the second example, I have a dataset where the concentration is in nanogram per milliliter and dose in milligrams. For the output units, I could select milligrams for the amount and milligrams per kiloliter for the concentration, which is equivalent to the original units in the dataset, but kiloliter is not a very practical unit. So instead, I will use the scaling feature and calculate the parameters using nanograms. Let's look at the slides for details. I need to scale the values in the amount column because they do not correspond to the selected output unit. A milligram is 1 million nanograms. So to display the results in nanograms, I have to multiply the amount expressed in milligrams in the dataset by 10 to the power of 6. And this is going to be my scaling factor. Now, Accepting these new units with the scaling multiplies the values in the column amount by the scaling factor. The dataset in the interface is automatically updated, but this is only an internal change in the application, and the original dataset remains intact. Instead of scaling the dose amount, I could use milligrams and scale the concentration. Let's do this step by step. Nanograms per milliliter used in the dataset are equivalent to micrograms per liter, and it is 10 to the minus 3 milligrams per liter. So if I want to display concentration in milligrams per liter, I need to set 10 to the minus 3 as a scaling factor. And this scaling factor is available in the shortcut list here. Changing time units works in the same way. In the dataset, each individual has several measurements during 24 hours. To use days as an output unit, I scale each measurement time given in hours by a factor 1/24. We hope that this feature makes your analysis faster and brings even more valuable insight. Look also at our online documentation for more information, and have a good week.